Hello everybody. In this video we're going to cover the questions that we cover today in our discussion review competition. I'll also work a few other problems too just for example's sake. So watching this video should be very helpful for you for the exam that's coming up. So let's start out with the first one. It says that it wants us to convert 2.05 times 10 to the fifth seconds into years. I don't know how many seconds there are in a year, so I'm just going to do it the way that I know how to do it, which is just go step by step for every conversion factor that I do have memorized. And so we'll start by saying 2.5 times 10 to the fifth seconds. Okay. Then we say for every 1 minute, there is 60 seconds. And then for every 1 hour, there's 60 minutes. And then for every 1 day, there's 24 hours. Oops, not 25. 24 hours. And then for every 24 hours, or sorry, for every 1 day, for every 1 year, there are 365 days. So now we can go through and cancel things, right? So we're getting rid of seconds here. Those are gone. Minutes are canceled. Hours are canceled, right? Day is also canceled. So we're left with 1 year. That means we're done with our conversion. All I have to do now is multiply the 2.05 times 10 to the fifth all the way across, which is all ones, and then multiply the 60 times 60 times 24 times 365, and then divide the 2.05 times 10 to the fifth by the product of the bottom numbers, right? And so the number you should get, the answer you should get on the calculator is something like 0.00065 so that's the answer you should get from the calculator, but we know that's not right because there's no sig figs there. There's too many sig figs there. So what I'll do is I'll move my decimal point 1, 2, 3 spots. And since I did it backwards, we already know it's going to be a times 10 to the negative 3. And then it's at 6.5. We look back at the question to see what the lowest number of sig figs available is. It's that 2.05 right there. That's 3 sig figs, which means my answer needs to have 3 sig figs, so I can just get one more 0 right there. There's no rounding, right? So it's 0. It's 6.50 times 10 to the negative 3 years. Right? So that's how you answer that one. Next one looks hard, but it's pretty simple, right? We're going 65 miles per hour. We want to go 25 miles. How many minutes will it take us? So again, this is one of those things where you're just trying to get rid of what you have to get to what you need, which is minutes here. So we'll start out with the 125 miles because that's the distance that we have to travel, right? And then we're going to try to travel that at a speed of 65 miles per 1 hour. And then our last step is that we have to change it to minutes right there. So that's going to be 60 minutes for every 1 hour, because there's 60 minutes every 1 hour, right? And so the answer that you should get from the calculator is 115.3846,154 or thereabouts, pretty close to that. And we try to now we got to change it to the right number of sig figs. We have 125 miles over here. That's 3 sig figs. But over here we have a 65, which is only 2 sig figs. Right. So we need our number here to become 2 sig figs. So the easiest way to do that is that we're going to get rid of all these guys right here and the decimal point. Okay, and bring it up to just 115. But 115, right, with or without the decimal point is still 3 significant figures. So we'll have to make it where the we have to round up the middle digit right here to 2 because it's a 5. So we'll get 120, right? And now that's got 3 sig figs, right? Because we rounded up to 120 from 115 without the decimal point, makes it 2 sig figs. And so the answer is 120 minutes, right? Next one, same as the top one, right? Here we're looking for, oh yeah, same as the top one, except we're going backwards. We've got 50 years and we want to go to seconds. Again, I'm just going to do it with the conversion factors I have in my head. I'll start with 50 years. I want to move towards getting seconds, so that's where I say for every 1 year, there are 365 days. For every one day, there are 24 hours. For every 1 hour, there are 60 minutes. And then for every 1 minute, there are 60 seconds. Right, so again, we cancel out all the things we don't want. So we don't want years, cancel out days, cancel out hours, right? We'll cancel out minutes. And look at that, all we're left, the only unit we have left then is the seconds, right? So all you have to do is multiply all the top numbers with each other, and then you don't have to divide by anything because the bottom number is 1. So the answer you should be getting from this is 1, 5, sorry, it's going to be a big number, 7, 6, 8, 0, 0, I think it's 5 zeros. So again, we have a lot of significant figures there, right? So we want to get it to only having 2 significant figures. So I'll take the decimal point that I have right here, and I'll move it 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces, right? So that tells me that my scientific notation will have a times 10 to the 9th, right? Times 10 to the 9th, that's what we have so far. And then we need to have 2 significant figures, right? So that's going to be 1.7. The 7 here makes the 5 round up to 6. So it's going to be 1.6 times 10 to the 9th seconds. And it's that simple. And the last one, I don't have a lot of room down here, but I'll do my best. Right, we're going at 65 miles per hour. How many feet am I going to travel in 22 minutes, right? So you're going to try to get from minutes to feet, right? Using this right here, the 65 miles per hour. So let's start out doing that. We have these 65 miles per 1 hour, right? Per 1 hour. I have a little helpful hint right there, conversion right there. For every 1 mile, there is 5280 feet, right? So for every 1 mile, there's 5280 feet. Okay, and just keep on going with your dimensional analysis. Remember, we're trying to get to minutes here, and we don't have minutes yet. How we're going to get to minutes? We got to change the hour, right? So for every 1 hour, there are 60 minutes. So good, we're in the minutes unit now, right? So now we just have to answer the question, which is in 22 minutes, right? So that we can get to feet. Right, and so now all you have to do is cancel out the miles, right? Cancel out the hour, right? And then also cancel out the minutes. That leaves you with just the feet right there, right? So all you have to do is multiply across 65 times 5280 times 22, and then divide all that by 60, right? Divide all that by 60. And so the answer you should get here is something like 120 5,840. And so again, let's look how many significant figures we have. We have 2 there for 22 and 2 there for 65. So we only need 2 significant figures. I'm going to drop all those, make all those 0, right? And then since I have a 5 here, it's going to round that 2 up to a 3, which means I have 130,000 feet. And that's how I would answer that. Okay, that's how I would answer that. Let's see here. So I think we should probably move on to working on some nomenclature. And so I'm gonna skip these guys here and get straight to the nomenclature. Since that was since we did that's what we did in class or in discussion. Let's see here. Yeah. So these are pretty easy. We have sodium and bromide right there, or bromine, which is going to become bromide because it's an ionic compound. You remember that Na and then Br. Na has a +1 charge, and then Br has a -1 charge, right? So if we do the whole crisscross thing, that means both will be 1. And so I don't know why I did that because all it's doing is asking you to rename it. So this is literally just sodium bromide. Next one, this is a calcium with an oxygen. So we'll do calcium oxide. Then we have another one here. This is lithium right here, 2 of them with 1 sulfide or a sulfur. So this is going to be lithium sulfide. And then MgBr2, that's magnesium right there, and that's bromine. So we put them together, and what do we get? We get magnesium bromide. And then the next one, this is actually a polyatomic ion known as hydroxide. Right, and it'll be one of the polyatomics that's listed on your chart for the exam. So this is beryllium here, so this is beryllium, if I can spell it right. Beryllium hydroxide. Right, beryllium hydroxide, missed the E there. So yeah, naming these are pretty easy, right, with the rules that we have. Let's try the next 6 now. We have potassium iodide. Potassium is K, right, with a plus sign, a +1. And iodine is a group 7, right? And so that would be an I right there. It's also a -1. So it's as easy as just K and I, right? Because if we do the crisscross thing, it's 1. And if we do the crisscross thing, that's also 1. Right, so that's Ki. Next one is magnesium oxide. So magnesium oxide is Mg. Mg is a part of group 2. So that's +2 charge. And then oxide is an oxygen, right? And that's a group 6. So that's going to be -2 charge. And so they're match made in heaven together, right? Because it's a 2 + 2 and a -2. But you can still do the shortcut where you crisscross. So both of them will have 2 of them in there. And so if you reduce that to the lowest common denominator, it would be just Mg for magnesium and then O for oxide, right? So yeah. Aluminum chloride, right? So again, aluminum is a metal that has a +3 charge, and then chloride is Cl with a -1 charge. Excuse me. And so it's just going to be Al, right? And then we only need one of them, one of those Als, because then they'll be balanced out by 3 chlorines that have a -1 charge, because it takes 3 -1s to balance out a +3 for the aluminum. All right, sodium nitrate, right? Sodium has a +1 charge, and the nitrate is NO3 -1 charge, right? And so, luckily for us, 1 and 1 makes it so that that's all it takes to balance them out. Again, you can do the crisscross thing; it'll still give you 1 and 1. So the only thing different about here is that we have a polyatomic right here. So we'll have to write that in there. So that would be Na, right? No subscripts because we only need one of them. Parentheses, and then NO3. And that's how you write that. And the last one on this page, we have calcium, which is Ca, right? And then carbonate, which was CO3. And so carbonate has a -2 charge, right? 2 minus charge. Calcium is from group, again, so the carbonates and nitrates, all those polyatomic stuff, there'll be a chart for that for you to look at. But yeah. And then for sodium, it's sorry, not sodium, for calcium, it's a +2 charge, right? So match made in heaven again, I'll only need one of each, right? So Ca, and then we don't even need parentheses for this because it's just going to be, they'll just be together for that, right? And honestly, you don't even need parentheses for this one because there's only one of those. So it would just be NaO3 like that for sodium nitrate. I won't count it wrong if you put parentheses around there if it's not needed, but just know that that's not really convention. You only put around the parentheses if you have more than one polyatomic ion. Here there's only one atomic ion. Oops. And here there's only one polyatomic ion, so there's no reason to have a parenthesis around it. But if you need more than one, that's when you need to put the parentheses, right? Okay, so let's keep going here. Let's write the formulas for these. So lithium, again, is in group 1, so that's going to be a +2 charge. Oh, sorry, not +2. +1 charge, right? Sulfate is SO4, right? And SO4 2 minus to be exact will be its charge, right? Just so you know, because I just noticed on me doing this now, sometimes when I say the charges, I always say either +1, right? But sometimes people will say like -1, but they'll write it differently, where they have like a 1 first and then a minus sign, right? Or even a 1 first and then a plus sign, like a 1 plus charge or a 1 minus charge. I sometimes say +1, -1. All these are the same, okay? So you can have, I won't count anything wrong. You can have the plus sign before the 1 or after the 1, or the minus sign before or after, and when you're labeling your ions, and I won't care, so don't worry about it, right? So this is freaking me out a little bit, so I'll go ahead and put the +2 up there. And so with a lithium that has a +1 charge, right, and with a sulfate that has a -2 charge, right, and so how many sulfates do I need to satisfy lithium, or sorry, how many lithiums do I need to satisfy sulfate, right? So they're going to need 2 lithiums. So the answer to this one would be Li2, right? And then SO4. No parentheses needed because it is only a single polyatomic ion, not multiple, right? Next one we got is beryllium phosphide. So beryllium is in group 2, Be, right? It's got a +2 charge, right? And then so phosphide is from phosphor. That's in group 5, and so if it's in group 5, 8 minus 5 is 3, so it has a -3 charge. And so this is one of those where it's easy just to crisscross. The 2 goes over to the phosphorus for the subscript, and then the 3 goes over to the beryllium as a subscript. And so that means that our formula is going to be B3P2, just like that. Okay, so we now have magnesium hydroxide, Mg, right? And so then we have the polyatomic ion hydroxide, which is OH, right? So OH actually has a -1 charge. Magnesium has a +2 charge. So here you could crisscross again, where the 2 comes over here to the hydroxide. The 1 comes over there to be the subscript for the magnesium. So all you have to do now is write it all out. So it's going to be Mg, right? And now we're going to have more than one hydroxide, right? And so that's why we'll need the parentheses. So it would be OH minus, right? And then there's 2 of them, right? To balance out the need for magnesium's 2 open spots there, right? Or 2 plus 2 charges there, okay? Sodium phosphate, so sodium you already know, +1 charge, right? And then phosphate, not to be confused with phosphide, but remember when it ends in 8, it's always one of those oxy anions. So phosphate is PO4 3 minus, or 3. Let me write that again. PO4 3 minus, right? And so this is a polyatomic ion again. So whatever you do here, if you need to have more than one of those, more than one phosphate to balance out the sodium, then you have to put parentheses around it. But since phosphate is already a -3 charge and sodium is only a +1 charge, we have to ask ourselves how many sodiums is required to make phosphate happy. And so it requires 3 sodiums, and that's why the answer will be Na3, Na3, and then PO4. So that's sodium phosphate, right? Let's do aluminum carbonate now. We saw carbonate earlier, so carbonate's formula is CO3, and it's got a -2 charge, right? A -2 charge, and then let's see here. Yeah, okay, so it's -2 charge, and then we have aluminum, which we talked about earlier. Aluminum has a +3 charge, right? So again, this is going to be one of those crisscross things, right? So the 3 from aluminum comes down here and becomes substrate for carbonate, and then the 2 for aluminum becomes the subscript for the aluminum, right? So that gives us then, for this formula, it's going to be Al, and then we'll have 2 of them because of the crisscross procedure. And then for the carbonate, this is where you put parentheses because there's going to be more than one carbonate. CO3, right? And how many of those do we need? Well, the crisscross shows that we need 3 of those at the bottom, so we'll put 3 there. And that's how you do those, right? That's how you do those. I'm just going to do a few more examples here to help you with the naming and stuff, just because we weren't able to get that far, right? So let's do some non-metal with non-metals, right? And by the way, if you didn't already know this, I think I said it in class, but remember that whenever you have a metal with a non-metal, we call that an ionic compound. We'll dive deeper into what ionic compound means later, but just know that that's an ionic compound, metal with non-metal. And then if you have, for example, these, where you have a non-metal with a non-metal, then these are called covalent compounds. All right, covalent compounds. And the only difference between the two, like I said, is that when you have a non-metal and a metal, that's an ionic compound where electrons are actually transferring, which we'll talk more about later, right? And the covalent compounds are compounds where they're both non-metals, and so they share electrons instead of one of them taking one, right? So, if you recall naming covalent compounds or molecules, it's super easy. You just use the Greek prefix for the word. So this first one here is got 1 sulfur and 3 oxygens. For the first name, right? For the first name of the compound, like here, it's going to be sulfur, right? This is going to be sulfur right there. You don't have to do mono sulfur because it's understood that when it's a first name and there's not anything in front of it, that's a 1. And then the next one will be trioxide for the 3 oxygens. So sulfur trioxide, right? So 3 for tri, right? And then we have this here, 2 nitrogens and 1 sulfide. And so this one has, we do have, since it's a 2 of them there, it will be dinitrogen. And then there's only 1 sulfur there, so it'll just be sulfide. Right. Next one, we have a phosphorus with 3 hydrogens, right? But whenever hydrogen is acting like a nonmetal, where it wants to take electrons, it actually becomes this thing called a hydride. Right, a hydride. So the answer to this one would be a single phosphorus. Phosphor, I don't think that's how you spell that. Phosphorus. There we go. And then we have 3 hydrides, so that would be trihydride. Not try like that, but try like the number 3. There we go. Trihydride. Just remember that whenever you have a hydrogen that's acting like it's a nonmetal, you always end it with an "ide," like you do with all the other nonmetals. Right? That's important. Okay. Next one, we have boron. Only a single boron, so we'll just write boron. But then we have 3 fluorines, right? So that's going to be trifluoride. Somehow, I don't think that's how you spell fluoride. So I'm just checking my spelling. I think that's right. Boron trifluoride. Maybe it's just my bad handwriting. Like I just can't read it. Let me just write that one out again. Right, flow. Yeah, I think that's right actually. I was wondering why I was having such a hard time spelling fluoride, but that's okay. So there's there's 3 fluorines right there, or fluoride. So it's tri. Only 1 boron, so no number needed there. You only need a number there if it's bigger than 1. So that's your answer, boron trifluoride. And then the last one on this page, we have 2 phosphoruses and 4 borons, right? And so that's easy. We'll just do diphosphorus. And then the Greek prefix for 4 is tetra. So we'll do tetra bromide. Right, so this particular phosphorus here needed 4, or the pair of them needed 4 bromines for it to be happy. That's pretty greedy. All right, let's do a couple more here. So here's nitrogen trichloride, and it's asking for us to write the formula, so that's easy. We've got a single nitrogen and then 3 chlorides. So that's Na, right? And then Na, sorry. It should be just N for nitrogen, and then trichloride means that there's a Cl, and there's 3 of them. So it's that easy, right? And then boron carbide, right? So carbide comes from carbon, which is the number 4 group number 4, so it can definitely act as a nonmetal. And so, how do we change it to non-metal, or how do we know that it's an ion there? We have the ion at the end, so this one will be just B for boron, right? And then uh, and then C for carbon, right? Boron boron carbide, right? Boron carbide. So that's good. Let's see here, and then the next one we have is dinitrogen trioxide. And so dinitrogen means two nitrogens, so that makes it easy. Na2, and then trioxide means three oxygens, so O3, and that's your sodium trioxide. Okay. And then last one for this page, we're doing phosphorus, which is just a P, right? Pentafluoride, which means it's going to be an F with five of them together. Right, and that's how you do that, right? That's how you do, and you do naming. Okay. So you have any other questions? Let me know. I'll be available in Teams, and I've posted for you already a practice worksheet that you can practice more on. It has answers on it too, so you can check your answers afterwards. But if you have any questions, just let me know, and I'll be around. And just remember, you do have an exam on Wednesday. All right. Thank you very much.